day. You could have those out, please, your notes out where we left off the other day. We're going to actually bounce around a little bit. Raise your hand if in here you were able to last night get your Math Excel done. Who's all the way done? Okay, a lot of you are ready. Okay, all right. You have, let's say, until the end of the week to go through and make sure it's working. If you had a timeout issue because the Wi-Fi was down yesterday, I don't want to ruin it, but it's not that much better today. Try it at home if you want. We can try it together on one of my computers to see if that works as well. But we do need to make sure that you got it signed, that you're able to go through and sign in. Okay. So last time we had class, we left off. We got done with, I think, questions 1. You're able now to go through, by the way, and sign into your calculators. So go through now, please, and sign in. Remember, your username is the first letter of your first name and then your last name. And your password is 1234. Have your notes out, and we got through the first 2 questions together. I don't think we need your calculator for much today, but some of you might. Looking at this, I guess the way of doing the greatest common factor, and I didn't want to give you too much today, the way of approaching the greatest common factor is to go through and make sure you understand what even a binomial is. And that is 2 terms separated by addition or subtraction. And a term can be either a variable or a constant. Looking at this right here, this whole expression is a binomial. Here's the left half and the right half of the binomial. They're separated by an addition sign. But there's binomials within the bigger binomials. So these right here are both also individually binomial, same thing over on the right. So looking at this, you look at the big picture first, which is everything that's up there, and your first question is, what can I factor out from the entire binomial? So looking at that, hands up please if you can tell me what the left and right half of the binomial share. No? Keep in mind, you're looking to factor something out from the left half and the right half. It has to be the same. Yeah, you're going to factor out the quantity x minus 5. So what you need to think of it as, and I wouldn't write this down, but in your head, what you're doing is you're going to divide out an x minus 5, put that in front, and what remains is going to be what you put in the parentheses. Now, in some of our work today, you need secondary parentheses, and when you have secondary parentheses, those are brackets. So I'm going to start off, what would I be left with after I factor out an x minus 5 from the left? I have the quantity x plus 6. Then I keep the sign the same, so I still have a plus there. And after I factor out an x minus 5 from the right, I would be left with a 2x plus 5. So we get to there. Questions on that piece? Now, the next thing you have to do is ask yourself, can I go further? Whether there's more GCFs to factor out, which means it's common to everything in its set, or are there like terms that I can put together? So let's ask this. Hands up, please, if you can tell me what the coefficient in front of each of those parentheses is. 1. You can distribute out to 1 if you need to, but you can just drop those parentheses if there's no coefficient in front. You have like terms then that you can put together. The x minus 5 is going to stay the same. Who can tell me what I'd have if I condense down on the right? Let's see if we can get 6 of you that can tell me what I would now be left with. If I condense down, what's left in that secondary set? Drop the parentheses, they really don't need to be there. What would I be left with on the right-hand side?
3x. 3x plus 11.
There you go. You're always going to be looking to take it as far as you can go. If there's like terms to put together, put them together. Questions on that one? And I'll tell you right now, the factoring I think that we do today is probably harder than the stuff that we're going to do tomorrow. Looking at what's there for B, hands up please, we'll wait to see if we can get 6. What's the GCF in B going to be? Take a look at what's there. What can you factor out from both halves of what we have written out in B? The quantity n plus n squared. Hands up please then if you can tell me what I would be left with after I divide out or factor out that m plus n being squared. No. You did something you can't do. It's that z plus, if I heard you right, z plus x squared. Can't do that.
B squared.
There you go. You can't take out the squared from both. Right? Because the reason being, this okay, those aren't equal to each other. But we identified the right base to factor out. Questions on that? Let's take a look at the next one for C. Hands up, please, if you can tell me what the GCF in C would be. We got one person, we're waiting for 6. Who wants to take these up front? R plus 2s being squared is what I'm going to factor out. Now, I'm going to need brackets there because this is going to get a little bit messy. It's okay. Who can tell me what I would be left with after I factor out the quantity r plus s squared from both the left and right half of this binomial? What do I now have? 1, 3, 2, 6.
Q minus Q quantity R plus 2S.
R plus 2s, did you say? Okay. On the left half, when I take out an r plus s squared, all I have is the p. Then I keep the minus sign. On the right-hand side, I've got a q, and then I've got an r plus 2s because there were 3 of them there. I took out 2. I still have 1 left. I wouldn't expect, especially an enriched student, to leave this as an answer. You can still go further. Look at what's inside here. You can distribute this out. And I'm not going to tell you what you get just yet. You can tell me, do it on your own. Distribute out and simplify what you have inside the bracket so we can go through and leave it as a set of parentheses. Hands up, please, if you can tell me what you would then be left with if you went through and distributed out what you needed to in C. What would you have as your final? We got one person and wait for. What would I now be left with? We got 1. Distribute out. I don't think that there's any like terms even to put together. 2 of us.
P minus Q R plus 2S cubed.
Make sure, and the reason I didn't say anything is some of you will want to just, and you'd say, and they did in the first section, they go through and say, I distribute out a Q, and that's not right. What are you distributing out to all of them? The negative Q, yeah. Don't forget that negative sign. I'll tell you right now, over the last, and I counted them up, it was 2 years ago I started keeping track of it, but I had 8 kids so far in the last 4 years. So I went back 2 years to find out what their errors were. They got 99s because of a negative sign. 8. Okay, you don't want to be that person. Now, I'm going to ask you to go through and do, D is probably the longest question that we're going to do today. One of maybe the top, it's probably the top 2, I guess, difficult ones that we're going to do today. It's actually not that difficult. I want you to get started, though. We'll give you a 30-second head start to get question D done. Factor it down. Take out your GCF. look at what's here. Hands up, please, if you can tell me what the GCF is for D to start. Wait for 6 of you, really. 3, 4, 5. And what are you left with after you factor out the quantity P minus 5?
P minus 5 minus 3P plus 4.
Close. What did you say was after this P minus 5? It'd be quantity, but what did you say it was? I don't know if I heard you right.
The quantity of 3P plus 4.
No, that's the second part of it. What goes first, though?
Oh, minus.
I don't know if I heard you say
Oh,
P. I thought I heard you say it's P minus 5. It should be a P plus 2. Now, once we get to this point, understand, there's a lot going on, but this is algebra that you all did back in Sprott. Who can tell me what we would do from here? I don't need the numbers. You tell me what we would do now. You're to this. This is on your paper. How do you work forward? What'd you say? I go through and distribute out the negative. So this becomes P plus 2, and then minus 3P, minus 4. And then all of a sudden, you keep going until you can't go anymore. And this is going to actually be a great question because a new door opens once we get to here. So on to this point, I distribute this out and I combine like terms. So I still have that same dangling P minus 5 that's been out in front every step. From here, the next thing that I would go through, I'm going to combine my like terms. And when I combine my like terms, I'm going to have negative 2P. And then 2 minus 4 is going to give me a negative 2. I'm still not done yet. Because now I'm going to look at the end of this. Hands up, please, if you can tell me what you think you're going to want to do from here. Particularly looking at that second set. We got one person who sees, 2. Follow it forward. By now, these things should start to be getting automatic. What do I say?
I got the negative 2.
Perfect. You can factor out a 2. You should factor out a negative 2. And when you take out the negative 2, what would you have left?
P minus 5 and quantity P minus 5.
Good.
Plus P.
No. If you can take out we're going to take out the negative 2, and what would you have left?
P minus.
Plus 1. Because you're dividing both terms by a negative 2. Another thing that you all, I don't know if you struggle with it or not, we don't show multiplication, it's implied. That's the operation that's getting done between the left and right half here. What's getting done here is also multiplication. So there's 3 terms being multiplied together. Does the order matter with multiplication? No. So I can drop all of those, and when I do that, your final answer that you all should work towards and be able to give is negative 2 times the quantity P minus 5 times the quantity P plus 1. You keep going to get it as far as you can. And there's a lot of steps on some of them. There's a lot. But again, the toughest thing that we're doing is combining like terms and factoring out a negative 2. Questions on that? This next one is interesting because there's there's 2 ways to do it. Both are right, and one is more right than the other. Hands up, please, if you can tell me one possible GCF for example 4. We got 1 person, 2, 3, 4. What's a possible GCF? A is one of them. And I'm not going to argue that you're wrong.
Negative A.
My reasoning for wanting to take out the negative and preferring you to take out the negative is look at what remains. If I'm looking to fully factor this, once I've taken out that initial GCF, my next step is looking at what remains and seeing if that factors. Are there numbers that multiply to positive 5 and add to negative 3? And the answer to that is no. This is not incorrect, but it doesn't lend itself to going forward very easily. So whenever possible, take out the negative. Now, the next thing that we're doing is, let's say, a double GCF, maybe even a triple GCF. Take a look at the first step in example 5. And it may help visually if you view it as 2 terms followed by 2 terms instead of 4 terms. So looking at what's there in the first 2, and make sure we're answering the question that's asked, look at just the first 2 terms. Hands up, please, if you can identify what the GCF of those first 2 terms in yellow would be. And what's left when you take the A and factor it out? Perfect. Look at the next one in green. Oh, this is just me separating out, sorry. So I take out the x minus y, or take the A out, I'm left with x minus y. Hands up, please, now, if you can tell me what the GCF for the green terms would be. And what's left when you take it, and by the way, is it positive B or negative B? Positive. And what's left when you factor it out? So now I've done 2 GCFs. Can I keep going? Is there a GCF there? Hands up, please, and you can tell me what your GCF here would be. Go ahead.
A plus B.
Careful. What's your GCF?
Oh.
X minus y, and what are you left with then? The A plus B that you said. The GCF that you're factoring out, it's almost like a double or triple GCF. There's a bunch of ways that these are shown to you. In all honesty, if we just put it under the umbrella of looking at it as a greatest common factor, there's less for you to do. Go through right now, please, and do out example 6 right now on your own. Looking at what's there, again, I view this in terms of 2 separate GCFs. Looking at the first 2, there's a GCF. Hands up, please. You can tell me what that GCF for the first 2 is that I'm going to take out. And what's left? Good. 3 in the quantity x minus y. Look at the next 2. This is where some of you may screw it up. Go ahead.
Negative A.
I'm going to take out a negative a, and what's left then? Now, if you're smart and you take that negative a out as opposed to a positive a, you can do another GCF. And the second GCF is going to be x minus y, so I factor that out, and I'm left with 3 minus a. Go through, please, and try the same thing now in number 7. Looking at this, hands up, please, if you can tell me what my GCF for the first 2 terms would be. We've got 1 person, 2, 3 of us, 4. What do you want to say, please? Go ahead.
6x,
And what is left after you take the 6x out?
A plus 2b.
Did you factor something out of the second 2? You can tell me what we could take out from the second 2. And we'll go on it a little bit. Go ahead. What kind of 1? Positive or negative? Before we put this together, understand that there's a lot of times that this is going to be awkward, because if you literally look over to example 1, what did I have you write out for? Is it 1C? Didn't I have you write down like that there was no GCF besides 1, so that there didn't have anything that you could factor out? 1 is the most awkward number because sometimes we'll need it as a GCF, sometimes we'll say that there's none. Sometimes we'll go through and say 1 is a perfect square, 1 is also a perfect cube. 1 is neither prime nor composite. Who knows what a prime number is? Hands up, please, you know what a prime number is. Yeah. There you go. It only has 1 in itself as factors. Composite means that you can get it by multiplying by more than just 1 in itself. And 1 is neither prime nor composite. 1 is a perfect square. 1 is a very, very awkward number. Now, we can piece this together and get our final answer, which would be 6x plus 1 times the GCF of a plus 2b. Now, all of the ones that you've had so far have been kind of easy because the first 2 terms and the second 2 terms always had a GCF. They were in a great order. Looking at question 8, do the first 2 terms and the second 2 terms have a GCF? No. What about the third and the fourth term? Do they have a GCF? No. I look at this, though, and I'm going to ask myself this. All right, so as it's given, I can't factor it down. It doesn't mean you're done. Can I reorder this so I do cause a GCF to happen? Absolutely. And there's more than one way that I can do it. I could either put the p squared, q squared, I could either move this term, the second term over here, or the third term over here. Now, when I went through and did it, I moved the second term there, and I positioned it so this happened. Because watch what's going to happen if I arrange it in this fashion. Look at the first 2 terms, and hands up, please, if you can tell me what my GCF would be for the first 2 terms. Oh, wow, 1 person, 2, 3 of us. We can do better. Go ahead. And what's left then? Hands up, please, and you tell me what the GCF for the second 2 is going to be. And what are you left with again? The reason that this arrangement is the one that works is now I can do a secondary factorization. You've done a GCF once, let's do a GCF again. I can factor out that remainder from the division, which is p squared minus 2, and that's what I would be left with. So always be on the lookout. Sometimes you will have to go through and rearrange things. Questions on that? All right. Now, we say this might be a contrast for some of you. I'll say this. The homework that you have in here, there's some times where it will actually be graded. As I think I said this to you all the other day, but there's some of you that literally can probably put the exam, the Algebra 2 Regents exam in front of now. Not having taken the course, you will have been able to do the whole thing and it will be successful. It'll be a walk in the park. It will be easy for you. And there are some of you that are going to have to put in a lot of side work, a lot of reps, a lot of extra practice to make sure that you're as successful as you can go through and be. The amount of work required from all of you is going to be different. And that's something that only you can go through and answer. So this grouping right here, I'll tell you right now, some of them you can answer, some of you can't. Like I would look at this question here. I look at this and go, all right, well, what type of factorization can I do in 27? Look what's there. Look at 27. Hands up, please, and tell me what you would do to factor that down. We got 1, 2 of you, 3. There you go. I can take out a GCF 3 minus x for sure. In 27, all 3 of them have it. And then I'd look at what remains. Maybe I can distribute. Maybe I can do more. Whatever. You have to decide how much you want to go through and do and how much it's going to take for you to be successful. I'll answer any question that you had if you want to come in between now and next class. But your homework is to get done as much as you need to from that grouping. There's 3 groupings we're going to bounce over. I think it's the page that is next. The factoring by GCF, the factoring by grouping, however you want to call it, it's difficult. And there's a lot of steps. It's not supposed to be easy. So you do as much as is necessary for you to be successful, but waiting for you next time we have class is going to be an assessment on it. All right? Let's bounce over, please. I think it's the page 6. Yeah. Let's bounce over to page 6. And we'll tell this to you now. Actually, before you go to 6, we'll have you go over, please, to page 7. And on the back of 7, you're going to see this rectangle here. This is all of the different types of factoring. Now, I'm guessing that these last two are going to be new to you, and I'm anticipating them being new. You're going to be doing those tomorrow. The one thing that we're going to focus on today is called the difference of perfect squares. Now, you all allegedly, I was told that some of you did this back in Algebra 1, which was back at Scribe. It's okay. It's a quick pattern to go through and pick up. Hands up, please, if you can tell me a perfect square number. Anyone that you want. Who can give me an example of a perfect square number? 4 is a perfect square number. Who can give me another one?
9.
64. There you go. Any number that times itself, or any value times itself, is going to be a perfect square number. So 10 times 10 is 100. 20 times 20 is 400. So 100, 400 are perfect squares. 225 is a perfect square. 256 is a perfect square. Yeah. You got to know your perfect squares at least out to, you've got to know out until 15 squared. You'll go through, there's a very easy pattern to go through and pick up on. When you factor this down, the pattern is called the difference of perfect squares. Difference means subtraction. And what you're doing is you're going to look at the left half of a binomial and the right half of a binomial. If both of them are perfect squares and there's subtraction between them, that's a difference or subtraction of perfect squares. And what you're going to have to do is take this and take the square root of the left plus the square root of the right and the square root of the left minus the square root of the right. Now, in the beginning, it's okay if you need to. The square root of t squared would be a t. The square root of 36 is a 6. So when I do the square root of the left plus the square root of the right and the square root of the left minus the square root of the right, what that's going to look like is the quantity t plus 6 times the quantity t minus 6. That's the pattern that holds true every time. If there's a difference between perfect squares, the square root of the left plus or minus the square root of the right. By the way, just so this will come up later, this is called, and these are called conjugates of each other. When the left and the right stay the same, the only thing that's different is the sign between them. Those are conjugates of each other. So x plus 5 has a conjugate of x minus 5. 7 plus y has a conjugate of 7 minus y. Now, this next one is going to cause a lot of you to fall flat on your face. And you're going to think you're right. There's a lot of you think you can factor this down right now. Like, I'm really, really sure that you're there. And you're probably wrong. Maybe I'm underestimating. The first type of factoring that we look for every single time is a GCF. Every time. So before you rush in and say this is a difference of perfect squares, is there a greatest common factor for this binomial? Yes or no? Hands up, please, when you can tell me what that GCF is going to be. 4. You can tell me what's left after you factor out the 4. You thought it was a difference of perfect squares, and you're not wrong. But there's a GCF to handle first. Who can tell me, please, what the final answer is going to be? We'll wait for 6 of you. You can keep going. You're not done. We've got 1 person, 2, 3, 4, 5.
A minus 4, or quantity of A minus 4 times the quantity of A plus 4.
That's not the final answer. You are very, very close. You missed one thing. What's missing?
4 times A minus 4.
Don't forget the 4 you took out in the beginning. Don't forget that 4. And when people make the mistake, that tends to be where it comes out. Questions on that? Go through right now, please. Actually, let's do this. Go through and do out question C right now. Look over to your calculators now. And when you do, you're going to get a quick fold that comes out to you. If you X out of it, you can always access it from the home screen. Go in right now and type in the expression. And when you're done, use your finger to activate the cursor there. And then if you click on this button right there, there'll be a drop down that says submit. Just submit it when you finish. Make sure, please, you put a multiplication sign between the binomial. Figure out what answer you're going to go through and give, and submit when you're done, please. We have 2 so far that have put it in. Is that right? Go through, submit when you're done. Fill in the multiplications if they're there. We got 8, 9 out of 28. 11. We're getting there. 13. 15. If you hit this, go up to the top there, we get a little drop down. You're doing that little triangle down. I think it says right next to the top, like submit. So we've got 18 of us so far. 19. Let's see what answers we're giving. Now, some of you do the minus first. All right, so we'll say this. If you're one of those first 14, it looks like some of them are just a formatting issue, which we'll get with time. Some of those first 14, though, either one of those answers is acceptable. If you were to go through and give this out, you would take the square root of the left plus and minus the square root of the right. So the left term, when you take the square root of 16m squared, would be 4m. The square root of the right, this would be 7p. And I'm going to put a plus and a minus between them. So my answer would work out to be 4m plus 7p and 4m minus it. So if you don't have that down, make the adjustment. Questions on those? All right. This next one's going to be a little bit awkward, and it's definitely an extension. Take a look at D. Is 81k squared a perfect square? Hands up, please, and you tell me what the square root of 81k squared is going to be. What's that? 9k. So I list that out up above. So I know that this is a perfect square. That's 9k being squared. Then on the right-hand side, I've got the quantity a plus 2 being squared. Is that a perfect square? Yes or no? The answer is yes. What times itself is going to give you a plus 2 squared? A plus 2. So now, the way that I format this is going to either make it a lot easier or a lot harder. I'm going to take the left plus the square root of the right, or sorry, the square root of the left plus the square root of the right, and the left minus it. So when I take this, I start off and say this plus this, and now a lot of you are going to make a real lazy layering mistake of this. Left minus the right would look like that. Because you're minusing both terms in the binomial, or minusing a quantity. Does this simplify down, or can you go further? You tell me. Can you do something to take this another step? We have 1, 2 of you who see. What can you do to this expression to go a little bit further? It's not a huge leap here. No, we can't do that because there's not a plus or a minus there. Okay? You can't take out a GCF. It's easier maybe than you think. Factor what? No, we can't take from both of them. Like that. Let's distribute out the negative so we can go from what we've got down to a more simplified version. If you can take that little step, do it. Now, are there like terms that we can put together? Are there? What part of 9K, A, and 2 can we put together? I missed it. There's nothing there you can put together. That's probably the second toughest one that we do today. Question E is kind of, I don't want to ruin it, but kind of easy. We'll give you a head start. Go through and try E on your own. Follow the pattern. And let's see how far we can take this. That's about half of you will get it right, maybe a little bit more. Hands up, please, and you tell me what you want to do to start this. Taking this there is one person, 2. What do you want to do? Okay, so she took the square root of the left. What times itself gives you x to the 4th, and that's x squared. This is a 9. So she literally went through and did exactly what we said we were going to do. Take the left plus the right, left minus the right. So we get to there. Are you done? Who can tell me, please? Hands up. You can tell me why you're not done. Go ahead. That's the difference of perfect squares the second time. That would be your final answer. Questions on that? Now, I think I gave you more practice ones from here. Go through right now, please, and do those. Go through and do 7 through 14. Hands up, please, when you can bang out any of those 6. There are no takers for any of them. Which one do you want to do? What do you got?
1 equals 4.
far, so good. You can give me another one. Go ahead.
A plus 3 and the rest.
Who's got another one? Go on.
9,
Okay.
5, 6, 7, 5, 6, 7,
Oh, okay, sorry, there's not a 9. What did you say for 10? I'm sorry.
5, 6, 7, 5, 5.
Good. Who's got another one that we can go through and do? Go ahead. 13, all right. Hang on, do this in steps. What did you take out first? You took out a GCF of 4, and what was left? (16m to the 4th minus y to the 4th, right? And then what did you do from there? And were you done? I get to hear I'm not done yet. We did 2 steps. You can actually go 3. Who can tell me what we can keep doing on this? Go ahead.
Factor 4.
Which one?
Where I'm put it 2m. Plus y and then minus y.
There you go. So over here, this is going to stay the same. This is 4m squared plus y squared. We can't factor down the sum of cubes, but this is going to become 2m plus y and 2m minus y. That would be the final answer. Go ahead.
11.
Okay, what do you want to do for 11?
So you have a GCF of 2.
Okay, so what do you,
So you divide it by 2 and you get 9. Quantity of 9a squared minus 49b squared.
okay,
And that's 2. That's the difference of perfect squares. So
good.
3a plus 7b. My quantity of, and then quantity of 3a minus 7b.
There's no 12 either. We just got 14 left to do. You can tell me what we do in 14. Go ahead.
I have 3.
Okay, so 3 times what?
81x plus 5 minus 2
Keep going.
and then the big square, so I got 9x squared plus 2 squared.
And?
then it's 9x squared minus 2 squared.
Okay.
And that's an answer to the big square, so I got 3 times 9x squared plus 2 squared times 3x plus 2 minus 2.
There's some over on the right-hand side if you want to practice more difference of perfect squares. There's one last thing that we're going to have you go through and do. These are going to be the first 2 rows when we talk about 1, 2, 3, 4. I'm going to ask that the first 2 rows, I got your names from a spreadsheet at the beginning of the year, so I don't know if they're right. Also, A, I don't know what your name is, and B, if you're like a Gregory and you go by Greg, or Jonathan that goes by John, or whatever. Or if I spelled your name wrong, because that happens as well. I need you to let me know. What I'm going to do now is I'm going to ask the first 2 rows. You're going to see your name as you come up on this big document here. I'm going to ask you just come up. Let me know if I have your name correctly, and if so, say my name is Tim. I go by Tim, not Timothy or whatever. And if I spelled it wrong, let me know. Otherwise, after you come on up, go set your calculators on the side. First 2 rows, come on up. 3 and 4, you guys can go put your calculators back now. Just tell me what name you'd like to go by. Everybody though, first 2 rows, come on over here, please.
My name is Benjamin Derringer. I go by
D, you go by Ben. All right, thank you.
I go by Cassie.
Okay, like K.
K-A-S-S-Y.
Thank you.
Eli Bassett.
I'm guessing, do you go by Eli?
Yeah.
All right, where are you on here? You're right there. Okay, you're good.
Yeah. Nathan Hunt.
Okay, where are you? Right here?
Yeah. I'm fine with it.
Nathan works?
Yeah.
All right. Okay. Thank you.
William, I go by Will.
Where are you? This one? So you go by Will?
Yep.
Okay. Next one?
Hannah Joy.
Hannah, where are you? And Hannah works? Okay, thank you. Okay.
Anna.
You go by Anna? Okay. A-N-N-A?
Yeah.
Okay.
That's Jared.
Where are you? Jared.
Hello, Hannah.
Hang on. This one here, you go by Jared? Okay, thank you.
Lucasella.
Is your brother Joe?
Yeah.
How's he doing at RIT?
Pretty good.
All right. And you go, what do you go by?
Luke.
You're good with Luke? All right.
My name is John McCartan.
John. This you?
Yeah, I go by John Paul.
John Paul?
Yep.
Okay. Thank you.
My name is Madalena Marcus.
Okay, where are you on here? Did I spell that right?
Yes, and I go by Maddie.
Maddie, like M-A-D-D-I-E?
O-Y.
Okay, thank you. Next two rows, come on up. Alexa. Where are you? Right here, you go by Alexa?
Yeah.
Okay.
Jaren, good.
Good? All right, thank you. Alexis, okay, you're good? And you're good? Okay.
Sander Milner. I go by Alex.
Alex? Okay, thank you.
Alexander Vogt.
Okay. Go by Alex, okay.
Spell my last name wrong.
What's your name, honey?
Leah Monaco. It's with an E, not an A.
Where? M-E here?
Yeah.
Okay, thank you. What's your name, honey? Where are you? Okay, you're good? Okay.
Robert Murkoff, I go by Robbie.
Okay. B-I-E?
Oh, why?
Thank you.
Nicholas Romanowski. Nick works me.
And I see K? Thank you.
I'm Jessica.
Jessica, and that's good? Okay, thank you. Jess or Jessica? Which one would you like? Jessica? Okay.
Taylor Payne.
And you go by Taylor? I remember you.
Yeah.
I can't even tell you how much you look like your sister. It's not even. Okay. You go by Talia? Okay. Yes? Good? Christina? Okay. No, and Noah?
Yeah.
Okay.
Abby. I go by Abby.
Where are you at, honey?
Right there.
Abby, A-B-B-Y?
Yeah.
Okay. Anyone else? If you go into Google Classroom, it's posted. The instructions are there. Okay? Thank you very much.
Yeah, and I had 85.
Walk into Mr. Nice Room.
You're laughing?
Grab one of each of those four on the side, find your seat up front, and get started on assessment 0. Okay? Guys, grab one of each of the 4 sheets over here, please, and find your seat up front. And get started on assessment 0, please. Well, grab one of each of the 4 on the side, find your seat up front, and get started on assessment 0, please. Okay, that's it. One of each of the 4 on the side, find your seat up front, and get started on assessment 0.
This is good. This is good.
Well, okay, thank you very much. Which seat are you in? Second or third? Second one, thank you. Guys, pick up one of each of those 4, find your seat up front, and get started on assessment 0. Line in, guys, there's 4 sheets, grab one of each of those, find your seat up front, and get assessment 0. Yeah.
I have no idea
I was doing that.
You need to focus on what you're doing. Kids, grab one of each of those 4 sheets, please. Find your seat up front and get started on assessment 0. That's assessment 0 at the top. Got in, guys? Find your seats. We're going on assessment 0. You have about 7 minutes or so. If you have a calculator and would like to use one, go ahead. 4 sheets over on the side. Make sure you've got one of each of those with the assessment 0 done. Here, 4 doors on the left. Best. Make sure your answers go in those boxes on the right. Use capital letters, please. more minutes to finish up. All right, so make sure, please, and this will be for everything we do during the year. So we'll ask, make sure your answers in the right, please, are in capitals. Make sure your name is at the top, and please, after your name, put a -4, because you're the fourth section of Enriched. So make sure, please, your name is at the top with a -4. We're going to ask that you hand those up and over now, please. And you should have also picked up a sheet that says All About Me at the top. We're going to ask you to go through, we'll give you about 5 minutes or so. Fill that in as well. So go through right now, please, and fill in the All About Me sheet right now. If you could hand those up and over, that'd be great. And fill in the All About Me sheet now. Go through, fill out the All About Me sheet now, please. We'll give you about 5 or 6 minutes to get that done.
about a minute and a half left.
All right, so what we're going to ask you to do now is, your name already should be on those. If you could hand those up and over as well. If you can get those, give me what you got.